All right, it's 9:45. I guess I'll go ahead and start. My name is Thomas Bachman. I work for the Noir Networks group of Cisco. This talk, or this session, it's not really a talk, is exploring the use of Docker, Vagrant, and other things in OpenDaylight infrastructure. And so just as kind of a background, this session was kind of selfish in nature for me because we had some needs for testing for our project, and then the more I started thinking about it, I realized, well, this is really kind of a lot of projects within OpenDaylight are going to have the same problem. So basically, the issues are, as projects are maturing, the test setups and the requirements are becoming more sophisticated. We have clustered data store testing. We have more sophisticated data plane validation. We have, it just sort of currently the way we currently do testing, it requires more nodes with each node having an incremental cost of RAM and CPUs and stuff. The number of projects in OpenDaylight is increasing. I mean, we had 23 in helium, we have 42 in lithium. Beryllium, we don't know yet how many projects are going to be, but it's something we need to kind of think about as things moving forward. And so, maybe Andy can correct me, we have 256 slaves, is that correct?
We have the capacity to go up to 250 slaves at the moment, and at most, right now, we're seeing about 125 in use.
Okay. And is it 1.5 terabytes?
It is 1.5 terabytes
okay.
of aggregate.
Yeah, and we had to bump that up recently because of...
That bumps twice during the last 6 weeks of
So, this is just projecting about, what we have today and where we're going. And so, we can add more infrastructure, but what's the cost and, what kind of trajectory are we on? So, what can we do? We do some things are perhaps easier than others that we can look at, like we can try and minimize Jenkins jobs by reducing test execution times. That makes it the job queue less because the jobs are taking less, and if a bunch of jobs spin up, they're retiring faster, so you don't have as long a queue. And sometimes that's a problem because people are trying to push through commits and they're waiting for a big backlog of jobs to get through. So it's nice to have that shorter execution times. You can create more scalable tests, tests that are gonna as they mature and you add more sophistication to them, that's not going to completely tear down your testing infrastructure. You can create a framework for doing more sophisticated test setups. Like, it'd be nice to have that where you can have, whether it's a Docker container or a Vagrant setup or what it is that you can has functionality already in it that you can use, because I think there'll be commonalities across projects for certain testing requirements. And so one of the things, my goal, and I don't think we're going to solve all these today, my goal with this session was to try and come up with a list of action items that we can go off and do, that, and investigate, because we have to, I think some of this is going to take some investigation. What can we really do with Docker? What can we do in terms of improving the execution times? What can we do with the test setups to improve these things? So that's my, if we come out of this session with just some of those action items, I'll be happy. So for those of you unfamiliar, today's infrastructure, we will spin up multiple instances for like clustering tests with JClouds, and the data plane tests are usually typically a single node with Mininet, and so it's a somewhat limited topology, and Mininet has its own limitations about what kind of data path testing you can do, and so we ideally like more sophistication in terms of scaling for clustered test setups, more sophistication for what we can test with data plane setups, more control over these kinds of things. And so these are some of the things we need to investigate. So in terms of test execution, there are some easy things we can do. I was talking with Ton, and he's like, well, one thing, the controller right now takes a while to complete, and that's mainly because you build it, and then as part of the build, you're running a lot of these unit tests, and there might be a speed up you can have of just the build, or if you could build it first and do that and do the tests separately, you can separate these things, and you might actually be able to have some benefits from that, depending on like when a test fails versus when something in the build fails, relatively speaking. So, apparently I'm here we go back to presentation mode here. Okay, so there may be some easy things we can do just in terms of how we are running things in terms of tests. That's just one example. And maybe Docker can be used to improve test times. For example, we discovered that with the current setup, if you're spinning up multiple instances for a test, you have to, the way the API currently works, you have to wait for the first instance to come all the way up before you can then spin up the other instances. So if we can have something where you have a containerized solution, it all comes up in one VM, and you can have these containers that come up with it. So you can parallelize it within the VM as opposed to waiting, serially for the VMs. There may be other things we can do. Some of this may be moot because there's plans to move to node pool, but it's still worth, I think, investigating some of these options. In terms of sophistication, we can also look at using containerized data planes. There may be issues that we need to investigate, I think, with using Open vSwitch with Docker containers on a VM, and that's some of the things, action items I'd like to have come out of this is to, we can figure out potential issues and whether or not they're solvable and whether or not we're getting benefit from some of this. That's one of the things to look at. Another item that's come up within the community, and I think it's going to come up more and more as we have more integrations, is OpenStack. I know that we want to have voting on changes whenever there are commits upstream in OpenStack. We want to make sure that that our integrations still work. We'd like to get more sophisticated with our integrations, like we'd have more sophisticated data plane tests and verification. I mean, it's one thing just to verify that the REST calls come down and work okay, but you'd also like to make sure that your NetVirt solution, with whoever it is, VTN, GBP, OVSDB, that still works as well. And so I'm not sure if Docker or any of these things are going to improve that, but it's something I think we should at least look at. And then we'll also want to open it to the audience for other ways that people can think of for improving the test environment. So those are my big things for this part of this. I'm going to turn over to Gary. He's going to talk a little bit more about Docker, and then after that, we'll kind of open it up to you guys because I'd like to get input on this subject and ideas from everyone, so we can then get a list of ideas. Maybe I'll put them on the easel over there, and we can come up with a list of things that we'd like to go off and investigate at the end of the session. So I'll go ahead.
Okay, great. Hi everyone. My name is Gary Wu. I'm with Huawei. So my experience and perspective is slightly different from Tom's. I was mainly interested in testing the ODL clustering performance and basically functionality. So it was very natural that I started exploring things like VirtualBox and Docker in particular to be able to spin up and down clusters. Particularly because I was doing a lot of things like testing different number of nodes in a cluster. So I basically put together a little bit of information here to share with everybody on my experiences. And I'm by no means an expert in Docker itself. So maybe some of the issues I ran into, some of you folks in the audience will be able to actually pitch in as well. Okay, so for those of you who are not familiar, Vagrant is a tool for basically managing virtual machines. And I think by default, Vagrant uses VirtualBox as its virtual machine provider. And it has good facilities for basically specifying consistent configuration for each of the nodes in a cluster. You can tell Vagrant to spin up as many nodes as you want for whatever testing you would like to do. So this is a quick basically agenda list of what I'm covering today. I'll just let you read through that, and I'll just jump into it. So the first thing that I'm doing is essentially, later on you'll see that basically I'm relying on the integration repository in ODL that has a deploy script for deploying basically ODL instances to cluster nodes. So a lot of my exercise was basically in properly setting up the clustered nodes up front in the first place. And I'm not actually using the ODL integration Jenkins infrastructure for that testing. This is actually running on my local machine. So I'm describing basically how I'm setting up my local machine. And a lot of these, like, if you are familiar, I don't want to go into too much details of that. That's redundant. So but basically, I'm using Ubuntu 14.04. I set up Vagrant latest version. I set up Docker latest version using basically the default installation instructions from their respective websites. And one last thing that I had to basically figure out was actually setting up DNS mask to ensure that I can configure the node names and have it be visible to all the cluster nodes that I'm spinning up. And this was because I found that at least with Docker and Vagrant, I'm not able to specify the static IPs, whereas with VirtualBox, it's very easy to specify the static IPs for each of the nodes that you're bringing up. So I end up having to use DNS mask to basically derive the IP addresses that got created as they're booting up. Okay, hopefully people can read this. So Vagrant essentially depends on what they call a Vagrantfile, which is a configuration file for specifying the configuration of the virtual machine that you want to spin up. And Vagrant by itself actually supports a Docker virtual machine provider. So as I said before, Vagrant by default uses VirtualBox, but they are really virtual machine agnostic. So you can actually choose what virtual machine provider you want to use. And Docker is not really a virtual machine, but Vagrant has basically added the capability to be able to use Docker to spin up instances, as you were. So since we may often need to spin up multiple nodes that are the same configuration, it makes sense to use Vagrant to control Docker in this case. So roughly speaking, what we're doing here, so the Vagrant files are actually basically Ruby files. Here you see on top of the script, I'm actually specifying the number of nodes that I would like to spin up. And I'm looping through the number of nodes and then specifying the configuration for each VM. And in particular, you'll see for each VM, I'm specifying the node number. Let's see if I can get the cursor up here. So I'm giving the host name to Docker, essentially. And then what the Docker instance is actually doing is, if you're familiar with Docker, you would normally specify a particular command that you would like to run within the container. And then after the command is executed, it returns control back to your host machine. So I don't want to do that. I want to actually have the container to remain running and accept commands. So the setup is essentially that the command that I'm running in Docker is actually sshd, and have it remain in the foreground, so that once this command returns, it actually will basically keep the SSD session open so that I can later connect to it using SSH directly instead of having to do everything through the initial Docker command line prompt. And then the very last line here, so this first part is I'm specifying that all the Docker containers should use this particular machine, which is my host machine IP address, to do the name resolution. So this allows me, basically allows each of the cluster nodes to be able to contact the other cluster nodes using the names I'm specifying. In this case, dnode 0 through 2, dnode 0, dnode 1, dnode 2. And then the next configuration here is because I actually want to somehow restrict the number of CPUs that each container is using so I can better grasp of the performance characteristics. Okay, this is the sample Docker file that I end up using. So the Docker file essentially you can think of it like an initialization script for the container. I would like each Docker instance to boot up with various things already installed. So on the very top is pretty simple. I'm installing OpenSSH, I'm installing OpenJDK, and also unzip, just so I can unzip the ODO binary. And then some of these, in particular this section here. No, thanks, Tom. If you're not familiar with Vagrant, Vagrant by default handles a lot of things using SSH, which means that you need to set up your containers correctly in order to allow you yourself or other tools to connect into the container using SSH. And the way Vagrant does this is that they come shipped with a default, what they call the insecure public key. And that's the default key that Vagrant system will try to detect to see if you have properly installed a key for the Vagrant system to access. And once they find it, they will actually, you have the option to actually have that replaced and recreated with something that is secure. And then so Vagrant can actually generate secure keys for you for each of the containers. But you need to put this insecure key up front first for them to detect it. So then after this, you can use the Vagrant SSH commands to connect to the individual containers if you need to. Okay, so this last part is basically something that I whipped up myself, which is, again, like I was describing, at least with Docker, I did not figure out how to boot up a container and have it and specify a fixed IP address for each node. So I have to basically rely on the Docker system to spin the nodes up, and then I run a set of commands to basically find out what was the IP address that was generated for each node. And then I create this name and IP address mapping to a configuration file called Docker container host, and I make sure that I have this host file added in the dnsmasa configuration. So this, in combination with the fact that I'm specifying the use of the host as the name server, allows the host as well as all the individual cluster nodes to be able to talk to each other via the names as opposed to the numeric IPs. Okay, so all that said and done, basically you will have spun up a set of, let's say, 3 Docker containers that actually don't have ODL on them. So by default, they just have Java. And then what I'm using is that in the ODL integration repository, under this directory, the cluster deploy directory, there's actually a deploy script, and I believe this is the same script that the ODL Jenkins infrastructure uses to deploy. So the fundamental assumption there is that, at least for this particular testing scenario, it's likely that every time you're deploying, the binary is different, right? So the script was created essentially to always start by copying a binary distribution file that you specify into the nodes that are now freshly sort of booted up. So it's always assumed that the nodes are fresh and clean so that you have reproducible environments. And it copies in whatever binary you are testing right now, and it unzips it and just runs it directly. This is the same one that I'm using as well. And later on, I'll open it up for maybe possible optimizations if this is not the particular flow that you're testing. And then likewise, there's a monitor script for monitoring the status of the clusters. And on the bottom, you see a sort of a sample output for what that cluster monitor script shows. And this was actually particularly helpful in basically being able to see whether the cluster nodes themselves have actually booted and started correctly. I'm finding that it takes maybe around 3 minutes or so for each node to come up. So, so sometimes you're not really sure like when you can start doing any sort of testing, REST-conf calls, stuff, whatnot. So this is a very useful script to have. And it actually shows you for each of the shards who is the leader, who is the follower. Okay, so a little bit on the observations that I have on running basically ODL cluster nodes in Docker versus VirtualBox. So first off, the Docker containers start and actually they start up much faster. And this is primarily because in using VirtualBox, you have to wait for the entire virtual machine and operating system to boot up, which itself could take a couple minutes per environment. And then so when you start doing things like, let's say you want to test a 20 node cluster, that time really starts to add up. Whereas the instance startup for Docker, it's in a matter of seconds. So that's
including the installation of the JDK and all that?
Oh, so the way Docker works is that when you install like all those things like that, the first time it does the install and then it snapshots the resulting file system. So in the future, when you boot up a Docker container of the same configuration, it's actually smart enough to not redo the whole thing. It just grabs a snapshot from the previously, grabs a copy of the previous snapshot file system. So when you, basically that expense is only incurred once initially. and thereafter, no matter how many nodes you start up, it actually is almost instantaneous, like seconds. But that's a very good point. If you have to do this with VirtualBox, then the VirtualBox initialization script will literally do the apt-get and download the whole Java binary and then install it, and that itself takes a lot longer than even just the VM startup as well. One of the downsides I found with Docker was that it is harder to configure the network versus VirtualBox. The first thing I mentioned already before was that whereas in VirtualBox, it's very easy to specify the static IP for each of the VMs that you're booting up. With Docker, at least I have not been able to find a way to do it. So I ended up doing this almost like a workaround using the DNS mask. But perhaps if someone knows how to do that with Docker, definitely please jump in. And then the other downside was that at least as far as I'm aware, the networking stack of configuration of Docker is a little less flexible compared to VirtualBox. With VirtualBox, it's very easy to say, I want to expose each VM as its own new IP address on the same local network, for example, on the host machine. So then you can do things like make connections to individual nodes from outside the host machine to the individual nodes. Whereas with Docker, it doesn't seem to have the capability to do that at this point. Which means that when you're booting up a cluster using Docker and you want to connect to it, you pretty much have to connect to it from either within the host machine or from other Docker containers within the same host machine. Or you need to start doing things like port forwarding and things like that. But once you have 20, 30 nodes, it's really hard to manage all the different ports that each ODL instance has to expose. Because the ODL instance exposes like, I don't know, 5 or 10 different ports on all sorts of different things, right? So that turns out to be pretty complicated. So, so Docker, like if you are able to live within this constraint, Docker is definitely much faster to start and run, but you can't connect to the individual nodes from the outside. And the last thing I found was that in my testing at least, I wanted to do various restrictions on the number of resources that each node is using, particularly on the number of CPUs. Where VirtualBox, the configuration is pretty simple. Just say, okay, 1 CPU, 2 CPU, 3 CPUs, and then the VirtualBox manager will take care of allocating that for you. In Docker right now, they deal primarily with CPU shares. So if you have 20 cores on your machine, it's not as easy to say, okay, I only want you to use just a single core. The closest I could find in Docker is essentially this concept called CPU sets, which is you explicitly enumerate the cores of the host machine that you want each container to use. So if that works for you, then great. Otherwise, it's a little bit more restricting. Okay, and here's basically some issues that I found trying to use Docker. The first thing is that, so Vagrant up is basically the command that you use to bring up all the Vagrant instances, sorry, the VM instances. I did not figure out why this is, but on occasion, especially when I'm starting a large number of old Docker instances, things will freeze. You see basically the output going through trying to initialize various containers, but it just somehow gets stuck, whereas normally it goes through like within seconds. When that happens, Control-C out of it, now you have to basically bring down everything and then restart. Not sure exactly what was causing this, but this is an issue that I did not observe with VirtualBox. And the next thing was I ran into a very strange issue on running on Docker once I start exceeding more than 30 ODL instances on the same host machine. So I can start up, let's say, more than 50 Ubuntu-based instances, fine. I can connect to all of them, and everything runs smoothly. Now, as I go through and start booting up ODL instances in each of the containers, as I get progressively closer to around 30 or so, I start seeing strange network errors on the host machine, like pings start breaking, like DNS resolution start breaking. but it's sort of sporadic. But as you start loading more and more ODL instances, then it becomes more and more persistent until after 30, 35, then it's almost always fails. But then if I go through and start shutting down the number of nodes, then once I bring it down below 30, then everything magically recovers. So this is a very strange issue. If anyone has run into anything like this, definitely appreciate any insights you may have. But because of this, that means that very practically speaking, I was unable to do any sort of testing above roughly the 30 node limits using Docker. Whereas, again, on VirtualBox, did not have such an issue. And the next point is actually not specific to Docker. Just a sort of general observation on running ODL clusters is that it's very hard to determine when exactly the full ODL cluster has actually completed initializing and is good for, basically open for business. And among other things, I ended up figuring out that I ended up having to check against each ODL instance what the CPU usage is. So I observed that during startup, roughly each node will go up to 100 or 200% CPU for a while, and then settle down a little bit, spike a little bit, and then finally settle down to about maybe 15, 20%. But when you're on a multi-core system, like obviously not everything runs at the same time, so then I'm checking the CPU usage and then making sure that it's actually stabilized before I start any sort of testing. And the next thing I need to check is actually whether the shard leaders have been elected. There are occasions when you're doing, let's say, more than 10 nodes, it takes a long time for the leader to get elected. I've seen it take as long as maybe 5 minutes before the leader actually gets pegged to a particular node. But then it's not consistent. So then I ended up having another script trying to detect, make sure that there's only a single leader that has been elected for each shard. And I can confirm that I can start actually doing the next step. I also seen cases where CPU has stabilized, shard leader has apparently been elected properly, but certain nodes, when you actually try to make a REST call, will just return 500. And then the only way to get rid of that is I end up having to terminate that particular instance and restart it. And then sometimes it'll come back up normal, and sometimes I have to restart it again. Like I said, so these are not Docker specific. These are also observed when I try to do it on VirtualBox. Basically, I end up having to do all these 3 tests before I can confirm that, okay, the cluster is actually fully up and running. That said, for the nodes that actually are running, it seems to work fine when some of the nodes are not running. So I guess the redundancy, high availability feature works. So. Okay, and the last point is just something else to bring up. So again, I'm using the integration repository deploy script to basically deploy the images each time on a fresh instance, which is great when you're always testing basically new code all the time, right? But if you have a scenario where you often want to actually test with the same ODL code, it actually may make more sense to actually build your own Docker image and have ODL instance directly already preloaded in it. So you don't even have to go through that step. That's it.
Great, thanks, Gary. So at this point, I was thinking I could just start with a Google document, and maybe we could start throwing things in here for just brainstorming on what we think we can do for where is Google Docs? What we can do. Nice. Do we have? There we go. I'd like to just kind of start. I mean, Gary pointed out a few issues of using Docker, but I could definitely see at least the benefit of using Docker with clustering testing, and maybe we can look at exploring some of those issues further. I've also talked with Rujing about some of the data plane things, and so there's some stuff we can probably maybe talk a little bit more about there. But I guess also I should ask if others have thoughts on, here we go, come on. New Google Doc, and we'll call this, we've got what, less than 15 minutes here. Let's see what we can do. Testing in ODL infra. I guess maybe first, now that we've done a lot of talking, I guess first I should open up to the audience. Are there any other things that people are aware of that we should be thinking about in terms of addressing these main issues of testing time, scalability, sophistication of data planes, anything that we haven't touched on with just Docker, Vagrant, and trying to think about other things that we can do in the ODL infrastructure?
The one thing we talked about already is the overhead of setting up the environment is 70–80% of the test job.
Test job, okay.
That's got to go away.
Because of what he just said, what if we just have like dedicated slaves that are already up and running and just having a script? So the problem with dedicated slaves is it gets back to exactly what we were doing before, where we did not have dynamic environments, where you're essentially forcing everybody into a queue of these are the only slaves that potentially you can test on. No, but how about certain jobs that run really frequently? Like verify master, like some jobs verification where they run constantly. Every time it checks to be it runs verify master that has a certain subset of tests. That's probably running more of like probably multiple things throughout most of the day as well. Meaning it's hardly down.
Wait, so just to make sure I understand, and just so everyone can hear, so you're saying for verified jobs, is there some sort of dedicated setup that we can use? Is that, did I capture that correctly? I don't know. Andy, did you want to?
Well, so part of the reason we moved to the current configuration that we're in now is that we found that the systems in a static configuration would not scale very well, first of all. We couldn't get through the tests in rapid enough fashion. As we trigger more of these jobs, the queue grows larger, right? The way we have it now is that the queue, the number of slaves will dynamically scale as we increase the queue. Now, admittedly, we still have the problem of that queue gets really large really fast, and the infrastructure that we're using can't necessarily keep up with it because we're within we have to work within the constraints of all of the various tests that we're doing inside the CI have to basically play with inside the same RAM and CPU constraints that we have. So everything's kind of having to take a share of those resources. Additionally, all of the integration tests specifically are bringing up labs. And the way those are working is that the leader, the robot framework system, is actually the slave in Jenkins. And then each of the slaves in that lab are slaves to the job itself. So they only come up after the job starts. And part of that is that you get a completely clean environment every time you run. Whereas a static slave, you have to make sure that all of your tests clean up properly. And we ran into a lot of problems before that, where jobs were not always cleaning up properly after themselves. We had to do a lot of housekeeping that caused a lot of problems.
For those of you,
I'm not saying that it's not doable. I'm just saying that it actually causes some problems.
If we use Docker containers, would we assume those containers are clean?
You could assume that the Docker containers are clean, and we do actually have a Docker instance in the slave environment already. The OBSDB project uses it for doing validation testing. So we have Docker in the environments. It's just a matter of starting to use it
Okay, I'll take that one.
Okay, I have a question about those IP addresses. Are those actually on the wire addresses?
By the way, people feel free to edit this document. I put it on the OpenDaylight meeting IRC. I can put it in there again. But if people don't hesitate to jump in, and if you've got ideas, throw them in this document. We'll keep this a living community document beyond this session. So, Jimmy, finish your thoughts. Sorry. Rujing, were you guys working about the IP address?
Yeah. My question about the IP address. How's the external address getting set up in these operating systems? I don't understand how that's working. Oh, okay. So we actually run into a problem with that. We don't manage the network infrastructure in our infrastructure. So there is no DHCP in that environment. If we bring one up, it'll actually cause problems in that environment.
So we don't. It uses DHCP, but we're not in control of the DHCP, as we were saying.
They don't actually use DHCP. What happens is the rack space cloud is an OpenStack cloud. As each instance comes up, it's actually handed an IP address due to the orchestration of OpenStack as it comes up. So there is actually no DHCP running on those networks.
So this cloud provider rack space, as is also Docker service, so they have Internoma, something like that. Yeah, that could be an option, right?
We could try to explore that. I'm not certain how well that would play with the way we've got the environment set up, because we have that requirement that we can't have external access. We can't have external world access to these systems because it'll cause a problem with the network tests. Because when you're externally accessible, people start using that, rogue stuff, which causes problems. Which is why our environment's kind of hard for us to bring new stuff in. We had to set up a dedicated subnet inside your system.
I mean, I was thinking because they manage the networking and the orchestration there. In future, or whenever they have this service available, we could just, instead of spin a VM and API, spin a VM with this, spin a Docker with this kind of configuration. And then we get that already in the network, we can use as a side IP address already with all the information that we need to know something like that.
We can talk to the rack space and see what they can do for us.
Yes. I think that probably is
Okay.
easier.
So, and actually, I realized we're getting down to like 5 minutes. Probably with the remaining 5 minutes, the best thing I can do is just hit on some of the high-level things that we know we can have people go out and investigate. One of which is maybe IP addressing for Docker, and I'll own that in terms of working with how can we make this more externally visible, at least from our testing infrastructure perspective, and still make all this work. Other items that we know we wanted to investigate. There was one, maybe I'll take this as well, to talk to some of the controller committers about the possibility of splitting out the build and test, that we can maybe improve something there. But another one that might be interesting is you've created Gary's taken the time to create the clustering testing locally. Maybe we can have a few people investigate what it would take to stand that up in integration, whether or not that's even makes sense. Because there are issues that will come up in terms of, where we talk about the networking side of it, but also just to flesh out the other issues, just from the clustering perspective. If anyone wants to jump in. Time frame? I don't know. I'm not going to. I mean, if people are going to. I mean, people aren't going to do much probably today and tomorrow. I think in terms of they'll be focusing on dev sessions. So, I would say this probably would start next week. And hopefully it wouldn't take. I don't want people to spend more than a week on these action items. I mean, people got other things to do, but
No, my question is because I was looking before we did this list. So this list that we are creating here is for action points after this, all these day events, or
yeah, and my goal was to have a set of action items that we can then, that people can go off and do. I mean, I knew we weren't going to solve these things, and we're not going to have all the answers. I just wanted to start the conversation. This is going to be something that's going to, and continue on the mailing lists. This is just a problem that I see happening. It's not, we're not stuck today, but more and more people are going to have clustering tests, more and more, challenges in terms of data planes. So these are the kinds of things. So I will also send this document to the mailing list. I guess I'll send it to integration. That's probably the right place for it. So if any of you aren't subscribed and are interested, please subscribe to the integration mailing list or look at the archives. You'll find it there too. And continue this discussion, because this is, and all the slides, I'll make the slides available as well, just so people can understand the context for what we're trying to do, the things that Gary's run across with his work with clustering with Docker. I'll just put the action items down here so we have them all in one place. Any other things with the remaining 2 minutes that people wanted to bring up in this context or had ideas or thoughts on? So we're officially 30 seconds over. So I guess that's all for now. Again, I'll make the slides available, this Google document available on the integration mailing list, and I'll send the slides out, and I'll probably put them up on a wiki somewhere. But thank you, everyone, for participating. Gary, for presentation. Thanks very much.